On hot summer and spring days, it's always nice to step into a cool building. However, the work and people behind what makes and keeps buildings so refreshingly chilled often go unnoticed. The chilled water services at UNC help keep research facilities, artifacts, and people cooled off. Amongst the chilled water, there are other energy services like steam, electric distribution, and water facilities. Delving further into chilled water at UNC, it is important to recognize that the chilled water services include 5 plants with 25 central chillers and about 28 miles of underground piping. The piping is a central component to chilling water and is seen to be color-coded throughout the chilled water facilities. Green pipes are the condenser water pipes, which is how water gets up to the chilling towers. Blue piping is chilled water that goes to campus, purple piping is reclaimed water, and light blue piping is return water that comes back to the plant at a higher temperature. There are a few main goals of the chilled water services that Lee Baker and the chilled water staff want to accomplish. One is to produce enough chilled water to meet campus needs. Another is to produce efficiently as possible. And lastly, to plan and prepare for future campus cooling needs and the expansion of campus. A large part of the goals of chilled water is their commitment to sustainability, which means using more non-potable water that can't be used for drinking. Other ways that can help save water and energy include slowing down systems and not relying on chillers as much on colder and less humid days. The overarching goal and mission of chilled water services is essentially to move heat and get rid of it through the atmosphere. In order to accomplish this goal, there are 3 main cycles. The first cycle to occur is the chilled water cycle, where the cool water is sent out to buildings and warmer water is brought back. Behind the scenes, this means potable water is sent to buildings and then brought back to the evaporators on the chillers. The second cycle is the refrigerant loop, where the refrigerant is carrying the heat as water chills. The water temperature is decreased in the chiller and impacts the refrigerant, since it decides how much of the refrigerant to use. After, the refrigerant makes its way to the evaporator, then to the compressor, and then back to the condenser. The third and final step of the system is the condenser water cycle, where the water is reclaimed, where reclaimed water is used and discharged to the buildings. Differing from the 2 cycles above, this is an open loop cycle, where non-potable water that was warmed by refrigerant goes to the cooling tower, where heat evaporates into the atmosphere, and the condenser water is made cooled and goes back into the chiller. Here at the Tompkins chiller plant is the cooling tower, which has 3 large fans sitting at the top of it to help suck warm air and dry air in. This helps warm water evaporate and also allows the cold water to fall into the basin at the bottom. This is a critical aspect of the 3rd cycle and is part of the open loop system and makes sure that the water is cold when it is sent out to the buildings. Another important aspect of all 3 cycles are the open and closed loop systems. Chilled water loop at the head of the whole entire system is a closed loop, which means that the water is reused over and over again and means it's much colder and does not have as much bacteria growth. The last cycle, which is the condenser water cycle, is an open loop system, which means it's open to the atmosphere and has a higher temperature and more prone to bacteria growth. Programming is another critical aspect of the chilled water services. Here is the Tompkins plant's control room, which helps control and manage water transportation and the machines that are being used. Next is the SCADA, which stands for Supervisory Control and Data Acquisition. Here is Travis Baston standing next to the SCADA interface, which helps manage and control the technology machines on the plants and is an automated system. Next is Nathan Hefner showing other machines like the variable frequency device and demoing how valves can open and close on the condenser cycle. Here are pictures of wires that show how complex the technological and programming system of the chilled water service is. Each plant has its own interface and systems, and all systems are interconnected. To make sure that chilled water services run efficiently, there's a budget. The budget consists of $25 million, and the top 3 things that are cost heavy include electricity, debt payments, and salaries. How the chilled water services gets paid are through the buildings, which they run water to. The building rate at the end of year 2021 was 0.193 cents per ton an hour. Water treatment is one of the most important aspects of the chilled water services. There are many reasons for treating, some which includes maximizing life expectancy of machines, keeping power consumption low, and helps keep water clean for bacteria. Nalco is the company that is used to help provide chemicals and create a water treatment plan specifically for UNC. Nalco also helps make sure that the system is automated and doesn't need to be watched 24/7. There are many ways water can become contaminated and rust, ruin, and cause machines to fill with debris and pipes. One of the ways is mineral scale. Mineral scale is the buildup of minerals that appear as white chalk substance. Another is corrosion. There are 3 types: general, pitting, and galvanic. And last is the fouling, which is unwanted growth in water that can stem from algae, microbacteria, and fungi. Thank you for watching, and hopefully you learned more about the chilled water services at UNC.